Hello everyone, here is Afrasya. Today we are going to solve Cambridge IGCSE Physics Paper 4 Theory Extended held on February-March 2020. Paper code is 0625 with variant 42. So let's start from question number 1. Question number 1 is given as a rocket is launched vertically upward from the ground. The rocket travels with uniform acceleration from rest. So, rocket starts from rest. It means that its initial velocity must be equal to 0. After 8 seconds, time is given as 8 seconds. The speed of rocket is 120 meter per second. After 8 seconds, the speed of rocket changes and it becomes 120 meter per second. Part A. Calculate the acceleration of the rocket. Here we have to calculate the acceleration of rocket. We know that acceleration is actually the gradient of velocity, or it may be defined as the rate of change of velocity of a body. So, I just write here acceleration will be equal to delta V over delta T. Here delta T represents the change in velocity and delta T is time. So I put values here. Delta V is 120 minus 0. I have to take the change in velocity. So 120 minus 0 over delta T is time, that is given as 8 seconds. So acceleration comes to be 15 meter per second square. The unit of acceleration is meter per second square. So I write here 15 meter per second square. Part B 1. On figure 1.1, draw the graph for the motion of rocket in first 8 seconds. We have to draw the graph for the motion of rocket in the first 8 seconds. You can see from the statement that rocket starts from rest. That it means that at time t is equal to 0, velocity also be equals to 0. At 8 seconds, the velocity of the velocity of rocket becomes as 120 meter per second. So we have to draw this on the graph. First of all, I label the points on the graph. The initial velocity is 0 at time t is equal to 0 and second is at 8 seconds. The velocity is 120 at 8 seconds. So I take a point here and I have to meet this point with this point. I use a ruler and draw a line. Starting from this point to this point. So, this line represents the motion of the rocket in first 8 seconds. Next part. Use the graph to determine the height of rocket at 8 seconds. So, now we have to find out the height of rocket. For this, we know that in the graph, if I meet this 120 meter per second point with 8 seconds, then it becomes a triangle and the area of speed time graph gives us the distance covered by the body. In this case, the distance is equal to height. So I write here height is equal to the area of this curve and it is a triangle, so the area of triangle will be equal to 1 over 2 base multiplied by height. Here base is 8 seconds, that is time, and speed is 120 meter per second. So when I simplify this, I get 480 meters. The height comes to be 480 meters. I write here 480 meter. Next part, from time 8 seconds to time 20 seconds. Two times are given. First is 8 seconds and other time is 20 seconds. The rocket rises with increasing speed but with decreasing acceleration. Here we have to draw this on the graph, that we have to start from 8 seconds to 20 seconds. We draw a curve that shows that the rocket rises with increasing speed but with decreasing acceleration. So first of all, we have to know about the curve after increasing speed but with decreasing acceleration. So I use a ruler and first of all draw the axis. Now I am drawing y-axis here. And x-axis. On this side. No. The curve for the increasing speed but with decreasing acceleration is represented just like this, starting from this point and rises in this way. It is velocity time graph. So I have to draw this curve on the graph. So let's draw this on the graph. First of all, we have to mention the time. It is 8 seconds and it is 20 seconds. And we have to start from this 8 seconds and end at 20 seconds. So I draw a curve just like this. This is a curve for increasing speed but with decreasing acceleration. So moving towards next part of this question. From time t is equal to 20 seconds to time 25 seconds, the rocket has a constant speed of less than 200 meter per second. So here we are given constant speed, means that its speed is not changing, its value remains the same, and it must be less than 200 meter per second. And we have drawn this curve in a time from 20 seconds to 25 seconds. So first of all, we have to know about the curve that represents the constant speed. This curve is represented by a straight line that must be parallel to time axis. I draw it on the graph just like as given. I again use a ruler and first of all I mark a point at 25 because I have to draw this curve between 20 to 25 seconds. Then I draw a line that starts from 20 and end at 25. So this is the graph for this question. Question number 2. Figure 2.1 shows an athlete crossing the finishing line in a race. As she crosses the finishing line, her speed is 10.0 meter per second. So first of all, speed is 10 meter per second. She slows down to a speed of 4.0 meter per second. Then her speed decreases and it becomes 4 meter per second. Part A. The mass of athlete is 71 kilogram. Calculate the impulse applied to her as she slows down. So here we have to calculate the impulse, and we know that impulse is the product of force and time. Therefore, I write here I is equal to F cross T, and impulse also be equal to change in momentum delta P. So here we are given mass and velocity. That's why I use the formula for impulse, which is equal to change in momentum, because momentum is the product of mass and speed. So I write here I is equal to delta P. It is equal to m delta V. So by putting values I get mass is given as 71 multiplied by speed is 10 minus 4, it comes to be 6. Impulse comes to be 426 Newton seconds, and it is approximately equal to 430 Newton seconds. So I write here impulse is equal to 430 Newton seconds. So let's move towards the other part of this question. Define impulse in terms of force and time. Here we have to define the impulse, and we know that impulse is the product of force and time. I use the same formula that I write before. Impulse is defined as impulse is the product of force and time. Second part, the athlete takes 1.2 seconds. Time is given as 1.2 to slows down from the speed of 10 meter per second to speed of 4.0 meter per second. Calculate the average resultant force. We have to calculate the resultant force applied to the athlete as she slows down. So we are given here time and velocity. In the part A, we also given mass. So I just write here impulse I is equal to F cross T. We have already calculated the impulse and it comes to be 430. So I write here 430 is equal to, here we have to calculate this force and time is given 1.2. So by rearranging, F comes to be 430 divided by 1.2 and it will be equal to 360 newtons. So the resultant force comes to be 360 newtons. Part C. Calculate the force required to give a mass of 71 kg and acceleration of 6.4 meter per second square. So here we are given mass and acceleration and we have to calculate the total force. So I use Newton's law. F is equal to ma. Mass is given 71 multiplied by acceleration is given as 6.4 meter per second square. Then after multiplication I get 450 newtons. So force comes to be 450 newtons. Question number 3. Figure 3.1 shows a model of wind turbine used to demonstrate the use of wind energy to generate electricity. The wind is blowing towards the model as shown. You can see this figure that these are the turbine blades and the wind is blowing in this direction. Part A. The mass of air passing through the circular area swept out by the turbine blades each second is 7.5 kg. Mass is given 7.5 kg. Kinetic energy of the air that passes through the circular area each second is 240. So, part 1. Calculate the speed of the air. We have to calculate the speed of air. We know that kinetic energy is equal to half mv square. Here we have to calculate this V. So I rearrange this equation. V comes to be kinetic energy multiplied by 2 divided by m, and it's V square. Then I take square root on both sides. It comes to be V is equal to square root of 2 kinetic energy, 2 multiplied by kinetic energy divided by m. And by putting value I get 2 multiplied by kinetic energy is given 240 divided by mass is given as 7.5 kilogram. So after simplification the speed comes to be 8.0 meter per second. The unit of speed is meter per second. So I write answer 8.0 meter per second. Second part, the kinetic energy of the air drives a generator. State the input power of the air passing through the turbine blades. Here we have to calculate the input power. So you can see from the part A that the kinetic energy of the air that passing through this circular area each second is 2.40. This is the energy that passing through the circular area each second. And we know that power is equal to energy per unit time. Here energy is given to 40 joules and time is per second, which means that time is 1 second. So power comes to be 240 joule per second. Our other unit of power is watt. So I write here 240 watts. Part B. The output current of the generator is 2.0 ampere. The output potential difference of the generator is 11 volt. Calculate the output power of the generator. Here we have to calculate the output power. We know that for the circuits that contains current and potential difference, the output power P must be equal to product of current and potential difference. So it will be equal to I is given as 2.0 multiplied by potential difference is 11. So P comes to be 22 watts. So I write here output power is equal to 22 watt. Second part, calculate the efficiency of the wind turbine. Here we have to calculate the efficiency. We know that efficiency is basically the performance of the wind turbine, and it will be equal to, efficiency is represented by eta. It will be equal to output power divided by input power multiplied by 100. Here output power is 22 watt and input power we already calculated is 240 multiplied by 100. So efficiency comes to be 9.2%. So I write here efficiency is equal to 9.2. Percentage sign is already shown here, so we don't write here again. So let's move towards the next part. The density of air is 1.3 kg per meter cube. Density is given. Calculate the volume of air passing through the circular area swept out by the turbine blades each second. Here we have to calculate the volume. So we know that density is equal to mass per unit volume and it is represented by rho. I write here rho is equal to mass per unit volume. We have to calculate volume, so I write V is equal to m divided by rho. Mass is already given in the question, that is equal to 7.5 and density is 1.3. So I get 5.8 meter cube. So volume will be equal to 5.8 meter cube. Question number 4, part A. Define the specific latent heat of fusion of a substance. First of all, we have to know about the latent heat of fusion, and then we are able to define the specific latent heat of fusion. Latent heat of fusion is the energy required to change the state. It is the energy required to change the state of substance. And when there is a word specific, it means that we have to specify the quantity. So, specific latent heat of fusion is defined as the amount of energy required to change the state to melt solid per unit mass. Here we have to specify the amount, that is per unit mass. So I write here as thermal energy required to change the state to melt solid per unit mass. Part B. Small piece of ice at 0 degrees C are added to 0.35 kg of water. Here mass of water is given. The initial temperature of the water is 24.5 degrees C. Initial temperature of water is given. The temperature of water decreases to 0 degrees C. Then the temperature of water decreases and it becomes 0 degrees C. The water loses 35,000 joules of thermal energy as it cools. All of the ice add to the water melts. The specific latent heat of fusion of ice is 3.3 into 10 to the power 8 joule per kilogram. We have to calculate part 1, the specific heat capacity of water. So here we have to calculate the specific heat capacity of water. That's why we use the data that is related to water. So, as we know that energy E is equal to mc delta T. Here m is the mass of water, C is the specific heat capacity and delta T is change in temperature for water. Here change in temperature is 24.5 minus 0 degrees C, that is for water, and we have to calculate the specific heat capacity C. So I separate the C and write as C is equal to E over m delta T. Here energy is given, that is 35,000 joules. So I write here C is equal to 35,000 divided by mass is given as 0.35 and change in temperature is 24.5 degrees C. So C comes to be 4100 joule per kilogram degree C. So here I write 4100 joule per kilogram and degree C. It's the unit of specific heat capacity. So in second part, the mass of ice added to water, we have to calculate the mass that is added to water. So we know that E is equal to mass and L. Here in E is the product of mass and the latent heat of fusion. We are given the latent heat of fusion in the question, and you can see from here the latent heat of fusion of ice is 3.3 into 10 to the power 5. We use this value and we have to calculate the mass. So I write here M is equal to E over L. Here E is the energy, that is equal to 35,000, and L is given as 3.3 into 10 to the power 5. So after calculation I get 0.11 kilogram. The unit of mass is kilogram, so mass will be equal to 0.11 kilogram. Question number 5, part A. Complete the sentence with words that describe the main process of the thermal energy transfer in each case. There are three methods through which the energy transfer. The name of these are conduction, convection, and radiation. So first of all, we discuss about what is conduction. Conduction is a process in which energy transfer due to the movement of the free molecules in the container. So that if we consider a gas, we know that gas contains a large number of free electrons, and when they collide with each other, they transfer energy. So the gas molecule transfer energy due to the conduction. The convection transfer energy due to the actual movement of the molecule. In radiation, energy transfer in the form of electromagnetic radiation. So the conduction occurs in the gases while the convection is related with the liquid. So going towards the statement, a man goes for a walk on a cool day. He touches a metal gate. Now the gate is made up of metal material, and we know that metal contains a large number of free electrons which remove thermal energy from his hand by. Now we have to tell the process by which thermal energy from the person's hand removed. So we know that the gate is made up of metal, so the energy here removed from his hand by conduction. I write here conduction. He holds the side of a cup containing the hot liquid. His hand gains thermal energy by. No, you can see from here that the person holds the side of cup, and cup contains the liquid, that is hot drink. So due to the liquid, here energy is transferred, and here the process that involves is convection. Some farm workers have lit a fire. The man warms his hand by the side of the fire. His hand gains thermal energy by. No, there are some farm workers who have lit the fire and the man warms his hand by the side of this fire. Now you can see here that the energy transfers in the form of radiation. The person gains the energy directly from the source. So here the phenomena that involves is radiation. So here the phenomena that involves is radiation. Part B. Describe in terms of particles the transfer of thermal energy through the metal of the gate after transfer from the man's hand. So we know that the metal contains free electron. Due to the movement of these free electrons, energy transfer. So I write here that the free electrons move and transfer energy. Next part is C. Figure 5.1 shows a car on a sunny day in a hot country. So you can see here is a car and there is a windscreen and object A mentioned. The object labeled A is placed inside the windscreen. It is used by the owner of a car to reduce the temperature rise of the air in the car. So this object A, it is placed inside the car and this object is used to reduce the temperature because it's very hot from outside and inside the car we have to reduce the temperature. So ring the most suitable material for the outer surface of object A. We have tell to the object or the material that is very suitable for the outer surface. Explain your choice. So we are given dull black, white black, shiny black and shiny white. First of all, we have to reduce the temperature inside the car. So we have to choose the color that is the best reflector. As we know that the black color is best absorber and shiny black or dull black, they both absorb the radiation. That's why we skip these two. White color is the best reflector and there are two colors, dull white and shiny white, but shiny white is the best reflector. That's why I write shiny white. And we have to explain the reason because it is a better reflector. Better reflector. Question number 6. Part A. Figure 6.1 shows crest of the water wave moving from left to right in the harbor. You can see that these are the crest of wave and these are moving in the right side. So part first, on figure 6.1 draw 3 more crests to the right of the point A. We have to draw 3 more crests on the right side of point A. So you can see here that the waves remain same and the crests are also remain same. It means that they are parallel to each other. So after point A, when I draw the crest, then there will be just a small curve at the end. I draw it. I am using ruler to draw it. First of all, I draw the straight line just like this. And then there is a small amount of curve just like this. And I again draw the crest and curve it from the end. We are asked to draw 3 curves. That's why I draw the 3 crust here. So this will be also curved at this end, just like this. So these are the 3 crusts after the wave passing through the point A. Part B. State the name of wave process that occurs as the wave passes point A. You can see that as the wave passing through the point A, it bends, or there is a very small amount of curve. So the process that is happening here is basically diffraction. Part B. There is another figure 6.2, and figure 6.2 shows the crust of the another wave moving from left to right in the different part of the harbor. This wave moves from deep water to shallow water. Part first. On figure 6.2, draw an arrow to show the direction of movement of the water after it has passed into the shallow water. This is the direction of wave. And these are the crust. So this is the deep water. When the wave passing from deep water into the shallow water, you can see that the direction of crust changes. First of all, it is straight and then it bends in this direction. So these are also the crust. And you can see that this is the wave direction and the crust is this. Both of these are perpendicular to each other. There is an angle of 90 between them. So when I draw the direction of wave at these curves, I also draw it at the perpendicular to these crust of wave. So I again use ruler and set at this angle. So I draw the line here. This is the direction of the wave. Part 2. State the name of process that occurs as the wave passes into the shallow water. You can see from here that as the wave passing from deep water into shallow water, its direction changes. So the process in which the direction changes is diffraction. So I write here diffraction. Next part. Complete table 6.1 to state whether each of the properties of wave increases, decreases, or remains same as the wave passes into the shallow water. So we have to tell these from the figure. The properties are wavelength, frequency, and speed. See this figure 6.2. First of all, count these crusts 1, 2, 3, 4, 5. There are 5 crusts in the deep water, and in the shallow water 1, 2, 3, 4, 5. Again there are 5 crusts in the shallow water. It means that the frequency remains same, because frequency is the number of cycles or number of curves. So I write here frequency . It is the number of crusts passing in each second. It is the number of crust passing through medium each second. Second thing is wavelength. Wavelength is basically the distance between two consecutive crusts. You can see from here, this is one crust and this is second crust, and the distance between them is equal to wavelength, and it is represented by lambda. So I write here the distance between two consecutive crust. And you can see from the figure that the wavelength in the deep water is lambda. I also represent the same on the shallow water. This is lambda. So you can see that this lambda is larger as compared to this. It means that when the wave or crust enters from the deep water into the shallow water, then the wavelength decreases, but frequency remains the same. So, moving towards the table, I write here wavelength decrease and frequency remains same. And we know that from V is equal to F lambda, if frequency is same, then V is directly proportional to lambda. So if the wavelength decreases, the speed also decreases. So I write here speed also decreases. Question number 7, part A. Figure 7.1 shows a converging lens. Converging lens is a lens that is used to converge the rays at a point, and the image I. Image is represented by capital I, formed when an object is placed to the left of the lens. The principal focuses are labeled A and B, and the center of lens is labeled with C. You can see in the figure that the points A and B are basically the principal focus, and C is the center of lens, and I is the image formed by this lens. Part 1. On figure 7.1, draw the two rays to locate the position of object. Draw the object and labeled it with O. So, on this figure we have to draw two rays to locate the position of object. First of all, we know that when we draw the diagram and form the image, then there are basically three rays. First ray is parallel to the optical axis. This line, straight line, represents the optical axis. First ray becomes parallel to the optical axis, and after refraction by this lens, passing through the point B, and then form the image. Second ray is that passing through C and comes straight on the other side. Third ray is that passing through the point A, and after refraction through the lens, it becomes parallel to the optical axis. So in the question we are asked to draw the two rays. So I use the ruler and draw these two rays. I draw first ray, and first ray starts from this point, passing through the focus and end at this point. Then after refraction, it becomes parallel to optical axis. Then I draw a straight line from that point towards this side. Second ray is that start from the same point on the image and passing through the center of lens. I draw the second ray. Okay, so I draw these two rays and you can see that they meet at a point. Then I draw the ray. I have to represent this by the arrow. That's why I draw a straight line here. And this is the object. We have to label it with O. So you can see that this lens forms the image at point I when the object is placed at O. Second part, reading the following distances that are equal to the focal length of lens. So first of all, we have to know about what is focal length. Focal length is the distance between the center of lens and focal point. You can see from here that the distance from this point C and A. On the other side, the distance from A to C, both are equal to the focal length. So AC and BC. AC and BC or CB both are equal to the focal length of lens. Moving towards the other part of this question. Figure 7.2 shows green light passing through the triangular glass block. You can see here that this is the ray of light that passing through the prism and then comes out of this prism. No, its name is green. Other light, that is red light, enters the triangular block shown in figure 7.2 along the same path as the green light. Part 1. On figure 7.2, draw the path of red light within the triangular glass block. In the part 1, we are asked to draw the path for the red light. So first of all, I redraw this line. That is that is green. This is green, and we have to draw for red light. We know that the wavelength of red light is larger as compared to this green light. So when red light and green light passing through the prism, then red light has less diffraction, so it will be above than the green ray. So I will draw it. So inside the prism, this will be the path for the red light. Moving towards the other part. So here is another diagram. Figure 7.3 shows green light passing through a rectangular glass block. This light is green light and it is passing through the rectangular block. Red light enters the rectangular glass block shown in figure 7.3 along the same path as that of the green light. On figure 7.3, draw the path of the red light within the rectangular glass block. We are given that this is the green light. First of all, I redraw the green light using the ruler. green light that is passing through the rectangular glass block, and we have to draw the red light. Know that red light has less refraction, that's why it will be above this green light. So it will be just like this. So this is the path for the red light inside the rectangular glass block. Third part, draw the path of the red light after leaving the rectangular glass block. So we also have to draw the path when red light emits from this rectangular glass block. We know that when a ray comes out of the block, it will be parallel to the incident ray. So the path of red light will be same as that of the incident light. So I redraw here again. It will be just like this. So this is the path for the light when it comes out of the glass. Question number 8. Figure 8.1 shows a circuit. The lamp has a resistance of 3 ohms. Line XY represents a uniform resistance. Wire of resistance 6 ohms. You can see that there is a circuit and the resistance of this lamp is 3 ohms. While there is a point X and Y, and the resistance of X and Y is 6 ohms. While there is another resistance that is 2 ohms, and this 12 volt is given potential difference. A represents the ammeter, and ammeter is the device that is used to measure the current. Part A. Calculate the reading on ammeter. We have to calculate the reading on ammeter, and it means that we have to calculate the current passing through the circuit. We know that there are a lot of resistance in this circuit, and if we apply Ohm's law, V is equal to IR. V is given, that is 12 volt, and we have to find out current. I will be equal to V over R. We don't know which value of R we have to use, as the ammeter is a device that is used to measure the current of this whole circuit. That's why we have to include all of these resistance. You can see here it is 3 ohm resistance, it is 2 ohm resistance, and we have to, this is X and Y points, and the resistance of this is 6 ohms. We have to add all of these resistance, and it comes to be R is equal to 6.0 plus 2.0 plus 3.0. Total resistance comes to be 11 ohms. So I write here V is equal to 12 and R is given 11. Answer comes to be 1.1 ampere. As current is measured in ampere, that's why I write 1.1 ampere. The reading on this ammeter reads as 1.1 ampere. So I write here 1.1 ampere. Moving towards the next part of this question. Part B. Figure 8.2 shows the circuit with a different connection to the resistance wire and an added resistor. You can see here that there are different resistance and there is a potential difference. Ammeter is also attached here. The length xy of the whole resistance wire is 2 meters. The resistance between x and y is 6 ohms from the previous circuit. It is 6 ohms and the length of this wire is 2 meters. Here the connect is made at Q where the distance xq is 0.60 meters. The distance between x and Q is 0.60 meters. Calculate the resistance of this circuit. We have to calculate the resistance of this circuit. And we also given the length. As we know that length is directly proportional to resistance. If I consider that for capital X, Y, resistance is capital R, and length is represented by capital L, and it is equal to 2.0 meters and resistance is equal to 6 ohms. Now for other X and Q, resistance is, I represent it with small r, and we have to first of all find out the resistance of this, while the length I represent it with small l. It will be equal to 0.60 meters. By using this equation, I combine and write small l over capital L is equal to small r over capital R. We have to find out the value of small r, and it comes to be r is equal to capital R multiplied by L over L. Now put the values here. R comes to be 6 multiplied by 0.60 divided by 2, and it comes to be 1.8. It means that the resistance between X and Q is 1.8 ohms. No, you can see that this resistance and this resistance 1.5. If I label it with R1, this resistance is R2, this is R3, and the resistance between them is small r. So you can see that start from R1 and move towards the left side. R1 and R2 are in series, and there is another point here that at that point there are two paths in which current can flow. It may pass through this or it may pass in this direction. It means that these two resistance are parallel. So what we have to do now, we have to find out the equivalent resistance of R3 and small r. For the parallel circuits, I write 1 over capital R prime. It is the equivalent resistor, and it is the combination of 1 over small r plus 1 over R3. So 1 over capital R prime will be equal to 1 over 1.8 plus 1 over 1.5. After solving, I get R prime is equal to 9 over 11. Now it is the resistance of these two. Now I redraw the circuit again, and it is the resistance R1. Again here is R2, and at this point there is a dot, and now I have combined these two resistance and it becomes R prime. You can see that when I complete this circuit, there is only one path for the flow of current. It means that these three resistance are in series with each other. So I just add this resistance. because we know that for series circuit R equivalent is obtained by adding these resistance R1 plus R2 plus R prime. So I just add all of these. 3.0 plus 2.0 plus R prime is given as 9 over 11. So when I add all of these, I get R double prime is equal to 5.8 ohms. This is the overall resistance of this circuit. So I write answer here. .8 ohms. Question number 9, Part A. State the name of the logic gate with the symbol shown in figure 9.1. In the figure 9.1, we have shown a gate and we have to tell the name of this gate. We know that the bubble above the symbol shows the NOT gate. It shows NOT gate. And this symbol is for AND gate. When we combine AND and NOT, we get NAND. So this symbol is basically for NAND gate. Part B. State the name of the logic gate with the truth table shown in figure 9.1. Here in the table 9.1, input is 0 and 1 and output are 1 and 0. You can see here that when input is 0, output is 1, and when input is 1, output is 0. So this gate is basically the NOT gate because it is the inversion gate, or it is the complementation. It changes 0 into 1 or 1 into 0. So I write here it is the NOT gate. Part C. No. Here is a figure. Figure 9.2 shows a digital circuit. You can see here is a circuit and inputs are A and B. Both of these input combines to give this gate and the output of this gate is C. Also these two inputs combine and give this gate whose output is D. You can see from here that this symbol is for OR gate and this symbol is for AND gate. The output of OR gate is C while the AND gate is D. When we combine C and D, it gives us NAND gate because this is the symbol of AND gate and there is a bubble in the front of this symbol. So this is basically for NAND gate. I write here NAND. The output of NAND gate is represented by E. Complete a truth table in table 9.2 for this circuit for all possible combination of input. Here A, B are the input, C is the output of OR gate and D is the output of AND gate while E is the output of NAND gate. So first of all, what is AND gate? We know that in the AND gate, when both inputs are high, then the output will be high. Otherwise, the output will be low. In the case of OR gate, if any one of the input is high, output will be high. NAND gate is basically the gate when we apply NOT gate over the AND gate. First of all, I draw the truth table using the ruler for all of these gates. So here we can see that here are two inputs A and B, and we obtain C, where C is equal to A or B, and D is equal to A and B. We taking the AND of C and D, C dot D, and then we get E, where E is equal to C and D, and then we apply the NOT gate. First of all, the inputs are 1 1, 0 1, 1 0, and 0 0. C is the output of OR gate, and in the case of OR gate, if any of the input is high, output will be high. So both of these inputs are high. So I write here 1, 0 1 also be 1, 1 and 0, because both of these inputs are low. D is the output of AND gate, and in the case of AND gate, when both of the inputs are high, then output will be high. Otherwise, it will be low. Now I have to take the AND of C and D. So first of all, inputs are 1 and 1, then output will be 1. Other possible combination are 0, because they include at least 0, which means that they include at least one low input. And E is obtained when I take NOT gate of C dot D. It means that I have to change 1 into 0 and 0 into 1. So I write here these. Now you can see this table and fill table 9.2. When C and D is 1, this C and D is 1, the inputs are 1 1. When 1 0, in this case, the inputs are 0 1. When again 1 0, then 1 0 are inputs. In the case of 0 0, inputs also be 0. And again we fill it for E, 0 1 1 1. So we have completed this table using these logic gates. Question number 10, part A. Figure 10.1 is a simplified top view of a flat coil. There is the alternating current AC in the coil. You can see here that this is a coil and alternating current is passing through it. Describe the magnetic effect of the alternating current. We know that when there is a alternating current, there will be magnetic field. It means that if the current is changing, as we know that alternating current is that in which direction of current is changing again. If I consider to draw the alternating current, I use the ruler and draw a straight line. Now I draw here alternating current. The waveform of alternating current will be just like this. On the time axis, on the x-axis I take time, and on y-axis I take the current. You can see here that if I consider this point at 20 ampere and this point at minus 20 ampere, then you can see that the current fluctuate between 20 plus value and minus value. It means that it changes its polarity between plus 20 ampere and minus 20 ampere. So the current also changes its direction again and again in the alternating. And I can simply say that when the direction of current is changing, then the magnetic field is produced. So I simply write here magnetic field produce which changes direction. Part B. There is another figure 10.2. Figure 10.2 shows a pen placed above the coil. You can see here that this is the coil and above here we placed a pen, and the base of the pen is made up of steel. The base of this pen, it is made up of steel. State what quantity is induced in the base of pen. So we have to tell that which quantity is induced in the base of pen, as we know that in the coil there is alternating current, and due to the alternating current there must induce EMF at the base of this pen. So the quantity that induced in the base of pen is EMF. Part C. The pen contains water. Now they have placed a small amount of water in the pan. State and explain the effect of quantity induced in part A. We know that in the part A, EMF induced on the temperature of the water in the pan. We have to tell the effect of EMF induced on the temperature of water in the pan. So, as when EMF induced in the base, the current will start flows, and there must the generation of thermal energy. Due to this thermal energy, the temperature increases. So we can simply write that temperature increased. Temperature increased because, now I write the reason. Current is produced in the base of pen due to induced EMF and then thermal energy is generated. Which causes rise in temperature. Question number 11, part A. The isotope hydrogen 1. We are given hydrogen isotope has a proton number of 1 and nucleon number of 1. Its proton number is 1 and nucleon number is also 1. Two isotopes of helium are helium-3 and helium-4. Helium-3 has proton number of 2 and a nucleon number of 3. Helium-4 has nucleon number of 4. Complete table 11.1 for neutral atoms of these isotopes of helium. So we have given data and we have to complete this table according to data. First of all, we know that number of proton is basically the atomic number. is equal to number of protons, which is represented by P, and nucleon number is equal to number of protons plus neutrons. So P represents protons and N represents neutrons. In the case of hydrogen 1 isotopes, proton number is 1 and nucleon number is also 1. And next we are given two helium isotopes, helium 3 and 4. Now first of all we consider helium 3. For helium 3 isotope, number of proton is 2, P is given as 2 and the nucleon number is 3. Nucleon number is equal to 3. So we see the table that what we have to find out. First of all we have to find out the number of neutrons for both of helium nuclei, and then number of electrons, and then mass compared to the neutral atom of hydrogen 1, and then we have to compare the masses of helium with the hydrogen. So first of all we consider the number of neutrons. So you can see from this formula that nucleon number is equal to proton plus neutron. I put nucleon number for helium is 3, so I write here 3 is equal to number of protons for helium is also 2, 2 plus n. So I get n is equal to 1, which means that number of protons in helium 3 is 1. I write here n is equal to 1, number of neutrons for helium 3 is 1. So second I have to find out the number of electrons, as you know that the number of electrons in the shell must be equal to the number of protons inside the nucleus. That's why I write number of electrons must be equal to number of protons. It means that number of electrons will be equal to 2 for helium 3. I write here 2. No, we consider helium 4 and do the same procedure. I write here for helium 4. Number of protons in isotopes are always same, as we know that helium 3 and helium 4 are the isotopes of helium, and isotopes are those elements that have same atomic number, means that the number of protons remain same but atomic number or nucleon number is different. That's why the number of protons of these isotopes remain same. For helium 4 the number of protons will be equal to that of the helium 3 and it will be equal to 2. Nucleon number is given as it will be equal to 4 for helium 4. So first of all we calculate the number of neutrons using again this formula. I write number of nucleon number is equal to 4. It will be equal to number of protons are 2 plus n. Then I get number of neutrons will be equal to 2. In the case of helium 4 the number of neutrons are 2. Know the number of electrons same in the case of helium 3, that the number of electrons must be equal to the number of protons, as the number of protons remains same in both of these isotopes of helium. So I write here number of electrons must be equal to number of protons and they are equal to 2. That's why I write here 2. In the third, mass compared to the neutral atom of hydrogen 1, we have to compare the mass of helium 3 and helium 4 with the hydrogen 1. So first of all, you can see from here that nucleon number for helium-3 is 3 and nucleon number for hydrogen-1 is 1. So we subtract them. 3 minus 1 is equal to 2, which means that the mass for helium-3 as compared to hydrogen-1 is 2. Similarly, we do for helium-4. The nucleon number is 4. We subtract 4 minus 1, it will be equal to 3. So it is 3 more and it is 2 more. Part B. An experiment takes place in the laboratory. So in this part there is an experiment that is take place in the laboratory. It is shielded from all background radiation. A sample of radioactive material is trapped in the aluminium foil whose thickness is 0.1 mm. A detector of ionizing radiation placed 1 cm from the foil records a reading. A piece of aluminium of thickness 5 mm is placed between the detector and the foil. The detector reading drops to 0. State and explain any type of radiation passing through the aluminium foil. So first of all, we have to know that how many radiations are there. So we know that there are basically 3 types of radiation: alpha radiation, beta radiation and gamma radiation. I write here alpha, beta and gamma radiations. And alpha radiations are simply the nuclei of helium, while beta radiations are electrons. Beta radiations are electrons, while the gamma radiations are electromagnetic radiations, and they move with very high speed equal to speed of light. Which one is passing through the aluminium foil? So I write here that alpha radiations would be stopped by 0.1 mm aluminium foil. Alpha radiation would be stopped by 0.1 mm aluminium foil. Second, beta radiation would be stopped by 5 mm aluminium foil. Third one is gamma radiation would not be stopped by 5 mm aluminium foil, and that's why it can pass throughout it can pass through it. So gamma radiation is basically the radiation that passes through the aluminium foil of thickness 5 mm.